Good evening. We're here today at Cold Springs High School with the Inspire students, and we're here to kind of investigate what the Inspires program is all about and learn from our students today.
Well, our project, Pioneer Venus, brought back data a while ago saying that there were unknown particles in Venus's lower atmosphere. And we are led to believe that these unknown particles could potentially be life or even unknown elements that are not even located here on Earth. And there's also this sulfuric acid region where it's not quite as the temperatures aren't as harsh as they are in the other regions of the Venusian atmosphere. And we also believe that we can find bacteria there and little single-cell organisms going through that atmosphere.
Okay.
And it's the probe that we're building, we're dropping down through the atmosphere, and as it's going through the atmosphere, gas is actually passing up through it, and we're analyzing, as we go down, we're just trying to see what we can find, and we're not exactly sure on a specific location for these particles, so we're just dropping from a range we're giving here, and we're going to try to estimate where exactly they could be, and as we go down, we're going to try and see if we can't find out what it is. And like you said earlier, it is hard with the trial and error, because sometimes, you have to build, but you still have to stay in your constraints, so the more you build, less you can be on that specific one.
I know one of the things that, because I've been able to see lots of presentations, is the battery life. It's very important because you've got to get to Venus, then you've got to deploy your probes and everything, collect the data, and you've got to have enough battery life to get that data back to you. So what have you found out from that standpoint of some of the issues with battery life, with weight, trajectory paths?
So what it is that a lot of times when you'll be calculating, you'll find that it won't work because you'll have so many things that can affect it, and you'll have to go back several times. Usually, I found that I personally have had to, and you'll have to redo from the start sometimes, because there are a lot of factors that go into it, and if one part is messed up, it will mess up all of it. So yes, it's very hit and miss sometimes with it. The actual probe itself can't be more than 5 kilograms. It's like about 5 books or so it's not a lot as far as our weight and our stuff can be. And they actually had us come up with our own environmental requirements and stuff, what we could survive, what we were supposed to be under. So it's really interesting.
Okay. Anything y'all want to add?
Everybody's environmental requirements will be different based on where we're going exactly. Mm-hmm. So all of the project requirements were the same, like the mass and the power and the all that kind of stuff, but everybody's environmental and functional requirements were different. So we had to take that into consideration.
It took a lot of research to figure out exactly what they were, because it's not just there, you actually have to dig for it.
It's quite time consuming.
It's very, very time consuming, and I don't know if your classmates realize how many extra hours outside of class that you all put in to develop this payload. I do want to ask you a question. You've got some interesting projects. How did you decide what your project was going to be, and how did you create your objectives?
They gave us kind of maybe general ideas of what you want to do. Like, do you want to study on the surface? Do you want to study in the atmosphere? Do you want to study the planet itself? Things like that. And we just decided that the atmosphere was the most interesting because it's the most harsh environment. And then we saw the vortices, so we thought that was really cool. And because they're huge, and we just want to know if they're like that on Earth, or if they could be one day, or we want to know more about the vortices, so that's why we picked that.
Okay. Okay.
Basically, all our teacher told us is whatever stands out to you, look into that. And the lack of magnetic field around Venus kind of made us think about it, because every planet has one except for Venus. And we wanted to figure out what caused that, and digging into that, we found out about the hot flow anomalies, and that just kind of built on.
And generally, it's everyone kind of decided that the atmosphere was the best. Everyone in a general idea, but then when we got specific, we actually looked at previous NASA missions, and that's kind of, we saw that they discovered some unknown particles. They weren't actually probing in Venus' atmosphere, they were using an infrared spectrometer, so they didn't quite get up. They could just pick up something was there. So we thought that was kind of interesting. We thought we'd dive in and see if we could find what that was.
And everyone's wondering, could there be life on other planets? And so our group unanimously decided that we would like to determine if, bacteria was in the acid rain zone, if they did have little single cell organisms going throughout their atmosphere and stuff.
And you may find out that there's a new element out there that might be beneficial here on
Quite a
Earth.
possibility.
Those particles, we did some research of them, and they were of a completely unknown origin. So as of right now, they're completely unknown to anyone. So we
cool.
hope to dig into that more.
That's exciting.
Our team's general mindset is basically, what could it be? So we're always trying to figure out what it could be.
You got a notebook, I see here, and your presentations, you will actually, at the end, you'll have some NASA people come in and observe you, kind of give you some feedback on what you're doing really well, compliment you on things you did well, but there's also going to be some constructive criticism. They're going to say, hey, have you thought about this? Have you tried this material? And so that'll be coming up. So kind of tell us the timeline from where you're at now to the process you'll go to the final competition.
Well, from here we have one other small review. I'll say small because it's not a final review. The really big review is in May, I think the 14th, and that is what really decides our score. It's really everything, and that'll be at UAH.
Okay, so now break it down. I know you have a display set up, so there's different things that you're going to be judged on, not just your project. So kind of go through that with us and tell us about all the different areas that you're graded on. And this is very time consuming because you're also, not only are you developing and building this payload, theoretically, but you're also going to design your display. You got to make brochures, so there's marketing involved in this as well. So engineering is just not, I'm going to build this piece of equipment or this project payload, but there's also marketing and design involved. So tell us a little bit about that.
Well, it's broken down. Our teams are broken down like there's a project manager, a deputy project manager, and then my team has 2 engineers. Some teams have 3, and then we have a CEA team. We have a CEA specialist and a CEA director. Yeah, and CEA is the community engagement activity. So they have to, engage the community. They have to do presentations for the community. They're the ones that make the exhibit boards.
Did you by chance, have y'all designed your t-shirts, designed your logo and what you're going to be doing? Did anybody by chance bring me a copy of all of those?
No.
I may
okay.
actually have a tiny thumbnail
Okay,
of what our
alright.
logo is.
Okay.
On the back page.
So it's a big marketing part of it too. So you're
There's a
you're
lot of
designing t-shirts, you've got a motto, your slogan or whatever you're going to be talking about. So it's pretty exciting. It's very, very involved. So give me your project title. It's not secret at this point, right? We can share
a little bit, not too much.
Not too much, okay, because it's going to air, so we don't want anybody else. Because we're in competition with people all over North Alabama, and I know one year there was a team from Texas. So this is pretty big, important stuff. So I don't want you to give away the big details that anybody could take from you, but without giving too much information away, share with us what you can, what you'd like to.
Well, our team is Team Vortex because we're studying the vortices on the South Pole of Venus, and our acronym is Venetian Oscillating Raging Tumult Exploration. So, and our slogan is, we'll take you right into the danger zone, and our payload name is Maverick. So we're going along with the Top Gun theme. Yes, and our logo is actually, it looks like the Top Gun logo, but we put the word Vortex instead. So it's really neat, and so that's what we're going along the lines with.